Okay, put the date on the top of the page, and we're doing exercise 2.3. And let's have a look at number 1. Now, just before we do, I just want to mention a couple of things. Prime numbers are numbers where the only factors of them are 1 and itself. So let me explain what we mean by that. If you've got number 5, the only factors of 5 are 1 and 5. If you've got 7, the only factors are 1 and 7. The only things that will divide into it are 1 and 7. However, if you've got the number 6, then the factors of 1 and 6 are, the factors of 6 are 1 and 6 and 2 and 3. So the number 6 is not a prime number because it's actually got other factors besides itself and 1. So numbers like 6 and 8 and 10 are called composite numbers. Okay, so composite numbers. So prime numbers can only be divided by 1 in itself. Composite numbers can be divided by other numbers besides 1 in itself. So let's go now to page 68 and look at number 1. It says, draw a factor tree for each of the following numbers and then express the number as a product of its prime factors in index form. So let's have a look. Number 8. If you've got the number 8, all you do is you split it up into numbers that multiply together to give it. So what two numbers multiply together to give you 8? The number 2 and the number 4. 2 times 4 is 8. Now number 2 is a prime number or a prime factor. You can't split that anymore, so you circle it. Now the number 4 is 2 times 2. Okay, so we draw a little V like this, and we put 2 and 2 there. So the number 2 is a prime. So we can see here that the prime factors of 8 are 2, 2, 2, which is 2 times 2 times 2. So that's the product. The product of 2 times 2 times 2 equals 8, and you can rewrite that in index form. That's 2 cubed. Okay, so what we've done, we've found the prime factors of 8, and we've written it in index form. Let's have a look at, let's have a look at B for number 1. If you've got the number 12, let's find out the prime factors of it. So 12 is the same as 2 times 6. Okay, so 2 times 6. And now 2 is a prime number, so you circle it. 6 is 2 times 3. 2 times 3 is 6. Now that's a prime number, that's a prime number. So 12 is equal to 2 times 2 times 3. Okay, so here's the prime factors of 12, and the product of them, the product of these prime factors gives you 12. Now, to write it in index form, 2 times 2 is 2 squared times 3. So this is the index form of this number here. Okay, let's have a look at D. If you want to show the prime factors and then show them as a product of its prime factors in index form, you write the number 36. Now, 6 sixes are 36, so you could go 6 times 6 is 36. However, we don't circle these because these aren't prime factors. So 6 is the same, can be broken down into 2 times 3. Now that's a prime number. That's a prime number. And this one, of course, can be 2 times 3. Okay, so here's all the prime factors of 36. 2, 3, 2, 3. So in other words, 36 is the same as 2 times 3 times 2 times 3. And as we've seen in earlier, if you rewrite these, that's the same as 2 squared times 3 squared. I'll do one more. Say you have G 68. All right, let's do this. That'll be 2 times 34. 2 is a prime number, so circle it. 34 is, let's see, 34, what goes into 34? 2. 2 times 17 is 34. Now, 17, what two numbers multiplied by themselves give you 17? There's nothing. So that's a prime number, 17. So you circle it. So 68 is equal to 2 times 17, which is equal to 2 squared times 17. So there's the prime factors of 68 written in index form. Okay, I want you to have a go at number 1. Now, number 2, for number 2, we're going to find the prime factors of the number, but instead of using one of these factor trees, we're just going to get the number. Like let's do the first one. If we do the first one, number 8, all you do, instead of using a factor tree, we're just going to divide it by numbers. So let me explain what we mean. So 2 divided into 8 will give you 4. Okay, 2 divided into 8 gives you 4. Now, 2 will also divide into 4 and give you 2. And 2 will divide into 2 and give you 1. So that here's our prime factors listed down. So the prime factors of 8 are 2 cubed. All right, so let's do another one by this division method. Let's do, which one shall we do? Let's do 168, which is M. So what you do is you write the number 168 and you start dividing prime numbers into it. So let's put 2 into it. 2 into 168 goes 84 times. Now 2 will also go into 84. So 2 goes into 84 42 times. 2 will also go into 42, and 2 into 42 gives you 21. Now 21, what will go into 21? 3 goes into 21. So 3 goes into 21 7 times. Now 7 is a prime number, so 7 will go into 7 and leave 1. Okay, so here down this list down here are the prime factors of 168. So it's 2 times 2 times 2 times 3 times 7. So writing that in index form, that'll be 2 cubed times 3 times 7. So there's the answer. Okay, do one more. Let's do quickly H. We've got 38, so write 38. Let's do a division into it. What goes into 38? 2 will go into 38, and that'll go in, let's see, 19. times. What number will go into 19? Actually, the only number that goes into 19 is 19. It's a prime number, and that goes in once. So the prime factors of 38 are simply 2 and 19. Okay? All right, what I want you to do is have a go at number 2. Okay, looking at number 3. Use prime factors to find the highest common factor of the following pairs of numbers. Now, we talked about highest common factor back in exercise 2.1. Let's have a look and see how we find the highest common factor by using a factor tree. So what you do, we've got two numbers. Hang on, let's get it writing. We've got 8 and 20. Let's use a factor tree to work out the factors, the prime factors of 8. So that'll be 2, that's a prime number, times 4. Oops, don't circle that because it's not a prime. Let's do that one again. 2 times 4 is 8. Now 4 can be written as 2 times 2. 2 and 2 are prime numbers. So the prime factors of 8 are 2 times 2 times 2. 20, let's do 20. That is 2 times 10. 10 can be split into 2 times 5. That's a prime number. That's a prime number. So the prime factors of 20 are, let's write 20 equals 2 times 2 times 5. The prime factors of 8 is 2 times 2 times 2. Now, the highest common factor, what you do, look at the prime factors for 8 and look at the prime factors for 20 and see the ones that are common. Those ones are common, those ones are common. So the highest common factor between 8 and 20 will equal 2 times 2, which is 4. So the highest common factor between 8 and 20 is 4. Now, let's do one that's a bit harder. Let's have a look at E of number 3. We want to work out the highest common factor between 24 and 56. So we use a tree to split this up into its factors. So 24 is 2 times 12. 12 is 2 times 6. 2 is a prime number, so we circle it. 6 is 2 times 3, and 3 is a prime number. So the prime factors of 24 are, 24 will equal 2 times 2 times 2 times 3. Now let's do the same for 56. 56 is 2 times 28. 28 is 2 times 14. 14 is 2 times 7. Now 7's a prime number, so the prime factors of 56 will equal, let's see, 2 times, going down here these circles, 2 times 2 times 2 times 7. So the highest common factor between 24 and 56, let's see, you've got 2 times 2 times 2 times 2. That's common with that 2 times 2 times 2 times 2. So the highest common factor is 2 times 2 times 2, which is 8. So the highest common factor between 24 and 56 is 8. So what I wanted you to do now is have a go at number 3. You should also be able to do number 4 as well. Okay, now let's have a look at number 5. You should have done number 3 and 4. If we have a look at number 5, which numbers are the product of these prime factorizations. So all you got to do, if we do like D, you've got 3 squared times 5 times 7 squared. Now you should be able to do this in your head, really. Hopefully you know your tables well enough, but if you haven't, you can use a calculator. 3 squared, 3 threes are 9 times 5 times 7 sevens are 49. Now you might need a calculator for this, but 9 fives are 45, so 45 times 49. Doing that the old-fashioned way, 49 times 45. 9 fives are 45, carry 4. 4 fives are 20, 220. 4 fives are 20, plus the 4 there is 24. Put a 0. 4 nines, what's 4 nines are 36, I think, 36. Carry the 3. 4 fours are 16, plus that is 9. So that will be 5, 10, carry 1, 13, 12, carry 1, 2,000, so it will be 2,205. Now let me just double check my multiplication by using a calculator. So let's get a calculator out. So 9 times 5 times 49 equals 2005. There you go, I got it right. Okay, so for number 5, all you have to do is multiply them out, and for some of them it might be best to use a calculator to do that. Although you should be able to expand them. Let me explain what it means. Let's have a look at number E. Have a look at number E of number 5. You've got 2 cubed times 5 squared times 7 times 11. Rather than type 2 cubed into your calculator, you should be able to do 2 cubed is 2 times 2 times 2. So expand it out first before you put it into your calculator. 5 times 5 times 7 times 11. Type all that into your calculator like that and get the answer. Okay, I want you now to have a go at number 5. And then you should be able to work through the rest of the exercise.